Hello Roblox, this is Royal Armament. My name is Felix. I work together with another member of Electra Engineering, which is a very small group on Roblox. We do a lot of performance, in quotations, for Roblox, the racing development basically. We are one of the forefronts in that. We do different types of designs compared to people in, for example, people that design the ATS system, the SS system. There's a couple more out there I don't exactly remember off the top of my head. However, this chassis basically strives to offer better innovation and better features and that kind of thing. So we're going to start here with the three main parts of the suspension. The rotor bracket itself, the upper and lower wishbone control arms. This does have caster, this does have camber. This also offers a lot of dive control, sway control, stiffness because of the springs that Roblox introduced a year or two back. This will basically be in our future performance cars. We will be doing a lot of testing and that kind of thing for future investors and whatnot. So let's start with caster. Caster is basically the offset of the chassis itself to the suspension bracket. I don't exactly have a picture to show, but this spring is actually tilted slightly forward to the right if we look at it from this angle. So looking at it from behind, it is looking towards the right side of the map. So what caster does is basically allows a little bit more stability, steering angle in a sense, over speed and when you're driving, when you're steering, that kind of thing. So even though I have developed a double wishbone suspension for Roblox, it doesn't exactly work with Roblox wheels because the cylinders are basically perfect cylinders. There's no way around it. You can't exactly bevel off the edges unless you try union sort of offsetting a tire itself. That's a very complicated process. Roblox just hasn't exactly made it yet. So as you can see, the entire chassis, or the entire suspension bracket itself, is almost the size of a 1x1 block. This means that we can put it in any number of vehicles, ranging from large and small. We can put it in basically anything besides maybe like a go-kart, you know. Even though go-karts technically shouldn't be using double wishbone suspensions, that's a different story. As we can see here, you have a lot of customization for the spring. If I show constraint details, you can see there's ball sockets, hinge socket. This will basically allow you to judge body roll, camber, steering lock, that kind of thing will all be in ball constraint. So if you can see here, restitution is basically how the chassis would perform. It will basically offer elasticity, as you can read in the description for restitution of the limit or how elastic it is, value in 0 to 1. So right now it's 0.1, so it offers a little bit of rigidity, a little bit of elasticity, just to give it a little bit of play. Upper angle basically judges the camber. Because these blocks are offset, this will basically offer you a little bit of movement between the camber. This should probably be lowered to 2 just for reliability issues. Twist, lower angle, and upper angle basically determine steering lock, that kind of thing. As you can see, these are 2 ball constraints. These are attached to the top and bottom piece. These will fit in place. Right now it's being spread out. So the ball sockets actually will snap in place. They don't actually need to be touching. You could have it just like this, and it will snap into place. This does happen when the game loads. The only anchored parts are these 4 right here. These are technically supposed to be welded to the chassis itself. As a caster is slightly slanted, camber, everything basically a normal car would have, besides certain functions like a trailing arm or whatnot. That goes into a little bit more complex kind of build. Roblox doesn't need that. So this basically will be our 0.6 or something super beta. You know, it's super primitive. It's in its infancy state. This design will actually function more into kind of like this design. This was developed about a year and a half ago. This is a fully capable light duty use, kind of something like a small size family sedan or something like that, where it doesn't need a lot of power. So this car has a steering column activated by a prismatic constraint. This will steer and push this bracket right here, this block, to go left and right. It does require a script. I think the welds in this car also require a script. These rods are completely decorational. At high intensity use, this suspension itself will snap. Honestly, this bar should be pulled back a little bit further. The spring actually should be connected to the control arm instead of the steering bracket itself. That offers a bit of a reliability issue. This car does not have camber. It does not have caster. It does not have anything a normal car would have. So this suspension will actually offer a little bit of a toe in and toe out adjustment. Basically, you would have a weld or a wedge on one side to offset the toe in or toe out slightly. That will require a little bit of calculations to determine what degree you want. However, the sizes of weld or wedge itself will determine basically how much toe in or toe out you have, although not exactly necessary for Roblox. So the chassis design itself, the wheels are powered by a script. There is a motor connecting to the fake brake pads. This actually makes the car all-wheel drive, I believe, right now in its configuration. As you can see, there's a couple more test subjects over here. This is basically a subject where we'll be potentially using prismatic constraints to compress the brake pads against the rotor itself, offering and using friction to stop the vehicle. That will probably be programmed into how controllers nowadays work, like the Xbox controller and whatnot. So we have a little obstacle course here. I'll show you how this suspension is not very reliable compared to the potentially more reliable double wishbone suspension, hopefully. I'll try to show how the suspension will actually snap. It's very realistic. Some cars out there will snap the same exact way. Everyday modern cars you see out on the road will do the same exact thing if you drive it just as hard. So right now I'm going to test this double wishbone suspension first. I'm going to play the game itself. As you can see, it snapped directly to the suspension itself. A little part there rolling away. That's nothing special. So you can adjust basically everything you want. Stiffness, damper. As you can see, it's very adjustable. It sways back and forth because it is a front suspension. As you can see here, this has no parts falling out of it. This is a pretty stable in this condition. This is a version 6. It says Electra Chassis V6 Electrum because technically it doesn't have a motor or anything. It's more like it's an electric car. It doesn't have any transmissions yet, or just anything really. This is a scripted car. We tried organizing the car the best we have. Drivetrain, powered motors and that kind of thing. Speed limit set, drivetrain. Right now it may be set to RWD, but technically it's I believe it is a all-wheel drive at the moment. As you can see, the suspension works perfectly fine. It is well built at this stage. This may potentially change in the future for more structural rigidity, that kind of thing. As we test here, the suspension is still technically active. It does glitch a little bit. Roblox does tend to do this. Everything programming is run live. So if we can zoom into the front steering column here, as you can see, it does steer left and right, pushing the bracket, and the spring on top of the steering bracket itself does jiggle a little bit. This is the reliability issue. As we can see here, it does jiggle upon use. Right now I'm trying to snap the suspension. This will take a couple attempts. This is a decently built suspension. It doesn't seem like it wants to snap now, but basically this wheel will turn upwards and stay in a locked position in this region. And the suspension basically will fail itself and it will not function anymore. Also, this suspension itself does not need to be can collided. The only places that need to be can collide is basically the four mounting brackets to the chassis itself. This will offer a lot more versatility. I could walk through the whole thing and it's still functional. The only thing that needs to be possibly managed is the motor connection between the wheel itself and the rotor, or perhaps even the braking in the future. I appreciate you for watching this video, and I hope you have wonderful success on your future projects.